Hi, welcome to Stellar Energy by Cody West, Period 7. So, solar radiation does come to Earth, but how much of it and where does it mostly go? Well, if we look at the diagram, we can see that near the equator, it gets more radiation than the poles. And if you can't read the highlighter to see how much they have, we can look at the table right here. So you can see that the poles are L to M and A to B, which is 3 and 3. But being the middle is G to H. We can look that right here. So G to H is 17. That is the highest number out of all of these numbers. So you know that would be the equator. In the graph right here of radiation on Earth, you can definitely see that it's much higher near the middle and much lower near the ends. So that would be the pole and the equator. So the equator being the middle and A to B being the pole, you can see that the Earth gets much more radiation in the middle than near the edges. So the picture of a star, the star is HR 8799. It's very similar to the sun, but yet which one emits more total energy? If we look at the very nice diagram here, the dotted line is HR 8799, which is this star, and the longer lines is the sun. We could definitely see that HR 8799 has much more intense energy, which leads them to more actual energy, total energy. So basically, HR 8799 has more total energy. Another thing that we could ask is, where do both stars peak? If we go back to the diagram, I have now labeled the lines, so it's more easy to read. So, a peak is basically the highest moment of the star's energy, which for HR 8799, its peak is the end of ultraviolet, and the sun's peak is about in the middle of visible light. So, again, HR 8799's ultraviolet peak and the sun's visible peak. If you're wondering what gives you a sunburn, it would be the sun's UV rays right there. That's bad V, sorry. So it's the UV rays. And if we look, compare to the sun's UV rays and HR 8799's UV rays, you would hands down get a sunburn. Way worse than you would on Earth compared to HR 8799's sunburns. If we just take a simple glimpse of the sun and HR 8799's comparity of the UV rays, HR 8799 is almost quadruple the sun's, which that's a lot of UV rays. So basically a 1 degree sunburn on Earth could almost be a 4-degree sunburn on HR 8799. At the beginning of this entire chapter, when Miss Newberg was talking about Earth's tilt, it really confused me. But luckily, we had a lab that really helped me understand tilt. It pretty much looked like that. This right here would be the string, and it helps you understand the protractor's measurements. And you would have the clamp and the solar cell here. And with the lamp here, you would move this to see the tilts. The more closer it was, I believe it was the higher. And the farther it was pointing this way, the lower. I mean, this station helped me understand angle because it was a little confusing, though, with the Earth's changing. Yet, the distance from Earth to the Sun stays the same, but after doing this station, I understood that the tilt as it rotates around could appear further or closer. And yet, when the tilt was facing more towards the Sun, that's where more direct sunlight was hitting it. Let's say your local weatherman just blatantly stated, "Today was a cold winter day." Then added, "As Earth orbits the sun, winter occurs when Earth is farthest from the sun." I would completely and utterly disagree. I would disagree because Earth never gets any closer or farther. It rotates around. And Earth, with its 23.5 tilt, doesn't make it any better. Earth would rotate around, never getting any closer, never getting any farther, just rotating around. And with all the previous slides and information before, you should agree. You should look at the tilts. The actual tilts station. All three of these factors lead to have your weatherman completely and utterly wrong. By Cody West, period 7.